Hi everyone, welcome to this episode of my podcast. I'm Dr. Kash Gupta. I'm a gastroenterologist and hepatologist in the UK. Trained at various places, including University College London, Royal Free Hospital, Oxford and Cambridge University Hospitals, and Harvard Medical School Hospitals, Dana-Farber, Mass General, Beth Israel Reagan Institute, where I did the majority of my research. And today I wanted to talk primarily about alcohol and how it's metabolized in your liver and what happens in your liver and how it causes damage. I recently did a video on alcohol mortality, and I think it's helpful to know what happens when it hits the liver and how it causes damage, because understanding some of the science behind it may help people think twice before they drink alcohol, or at least drink too much alcohol. So this is really about what happens when you take that first sip of alcohol and when it gets to the liver. And again, I just want to reiterate that this is an emotional subject for many people. A lot of people do die of liver disease. Primarily, it's one of the major causes for needing a liver transplant. And as I've said before, there are lots of stories I can think about from a clinical perspective from my work where people don't survive, unfortunately, due to drinking too much alcohol, or if they have other types of liver disease that they weren't aware of, and the liver tips them over the edge. And the scary thing about this is that most people just don't know. They're surprised when they've got such bad liver damage. And I think some basic education about this is going to be really helpful, and understanding the science behind this, I think, is useful for a lot of people. So it's a question I get asked a lot about, specifically, what happens when you drink. And I will do another video on all the other types of effects, negative effects that alcohol can have, but this is specifically on the liver and cirrhosis. And I think you could make a much bigger podcast video than this. So I'm really trying to shorten this down as much as I can. And it's not about saying, oh, well, wagging my finger at you and saying, you shouldn't be drinking, how naughty of you. And that's not particularly helpful. I think one thing I've realized that there are complex reasons why people drink, and a lot of people just aren't aware of the damage that it can do. But walking through the science, I think it will be useful. And when you understand what happens at a cellular level, like what is it doing in your liver, what are the byproducts that are being created, why it's harmful, why some people develop liver problems and other people don't, it puts you in a much better position to make decisions that work well for you in your own life, and perhaps at teaching other people that are close to you. And that's what it's really about. A little bit of knowledge can be very powerful. So we're going to cover the metabolism aspect, which is fascinating but complex. And we're going to talk about something called oxidative stress, which sounds scary, but I'll try and make it more understandable. And we'll see how this connects to your liver and longer term health stuff. And I've had a look at some research papers on this and try to distill it down. So when you have a drink, a glass of wine or beer on a Friday night, you've worked really hard, you feel like you deserve something to help relax you. Certainly that's the first feeling you get. It hits your bloodstream pretty soon after drinking. It gets absorbed very quickly through the intestine. But the liver, when it sees it, thinks, well, this doesn't belong here, let's try and deal with it. There's a whole system of enzymatic reactions that break down the liver, break down alcohol in the liver. The main pathways are in two steps. So the first is a group of enzymes called alcohol dehydrogenases, which we'll call ADH for short. And these enzymes grab the ethanol and convert it into something called acetaldehyde. Now, acetaldehyde is worth remembering because it's pretty toxic, actually, and it's the reactive molecule that can cause lots of trouble, and we'll get into that later. But for now, think of it as that problem child, the problematic middle child, which is what I was, in the pathway of alcohol metabolism. The second step is where another set of enzymes called aldehyde dehydrogenases, or ALDH for short, take that acetaldehyde and convert it into acetate. Acetate is much more relaxed. Your body can break it down into carbon dioxide and water, so you pee and breathe it out. So in theory, it's a clean process, but ethanol, when it becomes acetaldehyde, there is more to it. These reactions that allow for that require a molecule called NAD plus, or NAD, and they produce something called NADH. And when you drink, you're basically flooding your liver cells with NADH while using up NAD. And this shifts the balance between the two molecules. And why does that matter? Well, the balance actually interferes with how your liver handles fats. So it makes it harder to burn fats for energy and easier to store fat. So just from the basic chemistry of processing alcohol, your liver is already nudged towards accumulating fat. And we see this in people that drink too much. And certainly, when I see people with, and I see it on the scans, you see either a fibroscan or ultrasound, you see this fatty liver, and they don't have many risk factors for actual metabolic fatty liver disease. And you know they're drinking. And most people underestimate how much they drink, underreport it as well. So if you drink regularly or heavily, your liver accumulates fat. And there are other backup systems of enzymes as well. So cytochrome P2E1, or CYP2E1, is a family of enzymes that usually handles drugs and toxins. And many people who've done basic biology at university, at college, they'll have learned about the cytochrome P system. And when you drink consistently, your body ramps up production of cytochrome P2E1 to help clear more alcohol. So upregulates it. The problem is CYP2E1 is kind of messy at its job. While it's converting ethanol to acetaldehyde, it's also generating reactive oxygen species, or free radicals, or ROS. And think of them as molecular troublemakers. They're unstable, they bounce around, they cause damage to cellular structures. There's a third pathway as well involving an enzyme called catalase, which normally lives in these compartments called peroxisomes. It's a minor player for most people, but it can become more active in certain situations, such as fasting. So the main takeaway here is that none of these pathways are totally clean. They all produce acetaldehyde, and they all create some degree of stress on your cells. And the very act of clearing alcohol from your system has a cost. So that's one thing. Try and clear alcohol through normal systems. That can produce fat, and it can produce oxidative stress. Second thing to mention, those reactive oxygen species, the free radicals, these unstable molecules that get produced when your liver is working hard to process alcohol, some of these have byproducts. And certainly when you produce these products, the liver tries to handle them by producing antioxidants, things like glutathione, which is an amazing molecule that your cells make, plus various other enzymes that neutralize these reactive oxygen species before they cause problems. And oxidative stress is what happens when the balance tips, when you're producing more free radicals than your antioxidant systems can handle. And it's like having more mess than cleaning supplies. So when you're metabolizing alcohol regularly, especially through CYP2E1 pathway, you're generating a lot of these reactive species. The superoxides, the hydrogen peroxides, other nasty characters. And they start to overwhelm the defenses. And here's where it gets concerning. The mitochondria are particularly vulnerable to this. So mitochondria are these little structures inside your cells that produce energy. You've probably heard of them. They're called the powerhouses of the cell. and if they're overused, they can become damaged. They take nutrients and oxygen and convert them into ATP, which is basically the energy currency for your cells. So long-term drinking causes visible damage to liver mitochondria. They get enlarged, their structure becomes abnormal, and they don't produce energy as efficiently. Their own DNA gets damaged, and so it's like the power plants of your liver cells getting run down. And remember NADH buildup that we talked about? Well, NADH gets delivered to the mitochondria as part of energy production. When there's too much of it, the system gets backed up and you get more electron leakage, which means more of those free radicals, reactive oxygen species being generated right there in the mitochondria. And so when the mitochondria get damaged enough, it can actually trigger cell death. And there are pathways involving things like caspases, which are basically executioner enzymes that get activated. So caspases can get activated and your liver cells start dying off. Your body tries to fight back, it upregulates antioxidant defenses, it makes more glutathione, more protective enzymes, and for a while it can keep things in balance. But when alcohol exposure becomes chronic, the defenses get overwhelmed, depleted, glutathione reserves dry up, and you lose minerals such as zinc, selenium, copper, manganese, which are all those elements that help provide antioxidant activity, help mop up those free radicals. And without them, things just start getting damaged. So you end up with liver cells that are both producing more damage and they're less equipped to deal with that antioxidant pool, so that the free radical pool. So next, let's talk about the fatty liver, because this is usually the first sign that something's going wrong. And like I said, I see it all the time. When you see someone with a scan that's got a fatty liver, you know they're drinking if there are no other major risk factors. Now, that fatty liver is termed steatosis in medical terms, and it's incredibly common in heavy drinkers. About 90% will develop some degree of fatty infiltration in their liver. But the encouraging thing is that fatty liver itself is often reversible. So if you stop drinking, the fat can clear out quite quickly, weeks to months. But it's also a warning sign that your liver metabolism is already out of whack. So why does alcohol cause fat buildup? A few reasons which stack up on each other. First is the NAD plus and NADH imbalance, which we discussed. So when you have too much NADH, it suppresses the liver's ability to burn fat as fuel. At the same time, it promotes creation of new fat molecules. So you're burning less and storing more. The second is the acetaldehyde mess that's created in your genetic components. So the acetaldehyde can actually dial up genes that tell your cells make more fat. One that's mentioned, there's a couple that mentioned SREBP1C and PPAR alpha, PAPAR alpha. The third is alcohol interferes with something called AMP kinase, which is like a master sensor in your cells. AMPK normally helps prevent excessive fat accumulation when alcohol inhibits it, so you lose that brake on fat storage. And there's also a process called autophagy, basically your cellular cleaning mechanism. So autophagy allows mop up of dead components within your cells. You'll have heard about this during people talking about fasting and autophagy. We did a bit of work on autophagy during my PhD, but it essentially helps out clear fat droplets, damage cellular components, and short-term alcohol exposure can actually boost autophagy, and it seems protective, but chronic drinking blunts this process. And so the cleanup crews essentially don't turn up for work. And so you've got multiple forces pushing fat accumulation, which would normally be not happening. And fat builds up in the liver and gives you this steatosis, as we term it medically. And the scary thing about this is most of it's very silent. So you don't feel anything, you don't know about it. Your liver enzymes might be up a little bit or might not be up. And so that's why you can still get liver disease even with normal liver enzymes. And that's what makes it really tricky and scary. We see people get liver cirrhosis who don't have very high liver blood tests. And when you drill down, it may be that they've got other coexisting problems with the liver, which make you more susceptible to even smaller amounts of alcohol or fat. The next thing I want to talk about was the gut connection. So this is really interesting. And it shows how alcohol isn't just about the liver, but the gut damage it could cause can also affect the liver. So chronic alcohol use changes your gut in several ways. It affects how your intestines move. It alters bile acid levels. It shifts your microbiome, which is the community of bacteria living in the gut. And you tend to get more harmful bacteria growing while the beneficial ones decline. So here's the important part, that alcohol and acetaldehyde damage the lining of the intestine. Specifically, they mess up something called the tight junctions, which are the junctions that help seal the cells together in the gut lining. And when that becomes compromised, your intestines become more permeable, they become more leaky. And you probably would have heard that term, leaky gut, which I think is thrown around quite liberally in some areas. And you really have to understand specifically what that means. You know, if you eat food, certain types of food, it doesn't mean that you're automatically getting a leaky gut. And so when your gut is permeable, bacterial products can escape into your bloodstream. One in particular that's been studied is lipopolysaccharide, or LPS, which is particularly problematic. And LPS comes from the outer membrane of certain bacteria. And it's a red flag for your immune system. Your immune system knows to attack that. So LPS can travel through the portal vein. 75% of the blood that goes to the liver comes from the portal vein, which essentially drains the gut. And so, and when the bacteria, the LPS, gets to the liver, it doesn't react very well at all. So the liver has immune cells called the Kupffer cells, and they have receptors called toll-like receptors, and they recognize LPS and sound this alarm. This triggers inflammatory signaling pathways. You get production of messengers, inflammatory mediators such as TNF-alpha, interleukin-1, interleukin-6. And these signals recruit immune cells into the liver. Neutrophils come rushing in, and it's like calling in reinforcements for battle. But in this case, the reinforcements cause collateral damage to the tissue. And so you get oxidative stress that we talked about earlier, and that amplifies inflammation as well. Inflammation generates more oxidative stress, and it becomes this reinforcing loop, unfortunately. And there's another layer on top of that. So when liver cells die from all this oxidative damage and inflammation, they release their contents. And some of these contents act as danger signals that activate things called inflammasomes, which ramp up production of inflammatory molecules. You also get an adaptive immune response. Acetaldehyde and products of fat break down, can bind to proteins and create these modified proteins that immune systems see as foreign. And your body starts making antibodies against its own liver tissue, which then creates even more inflammation. And the strange thing is, people with alcoholic liver disease seem to end up immunocompromised even while their liver is inflamed. So even though you're getting this higher immune reaction, I think what's happening is that that immune system is getting exhausted. And so they end up having a dysfunctional immune system at the same time as being inflammatory. So they become very susceptible to infection, and we do see people with liver damage or inflammation being highly susceptible to infection, and many of them die from it. So what happens if this cycle continues over years? We get into the territory of fibrosis, which is scarring the liver, and cirrhosis, which is essentially permanent scarring. And when your liver gets damaged repeatedly, it tries to heal itself by laying down connective tissue. There are cells called hepatic stellate cells that get activated and start producing collagen and other matrix proteins. And essentially, acetaldehyde activates these stellate cells. And so, remembering back to the beginning, acetaldehyde being a very damaging molecule, also, rather than just promoting inflammation, also promotes this production of scar tissue by it's stimulating the stellate cells and laying down collagen. The reactive oxygen species and products of fat breakdown also contribute. They promote the stellate cell activation and collagen synthesis. So everything we talked about, acetaldehyde, the oxidative stress, the inflammation, it all feeds into the scarring process. And over time, with repeated cycles of injury and healing, the scar tissue accumulates, the normal architecture of the liver gets disrupted completely, and blood flow through the liver becomes impaired. And so this is essentially what is cirrhosis. And cirrhosis brings a whole load of complications, such as increased pressure in the veins. So imagine when the liver's scarred and you've got the gut here and you've got the vein in between, the pressure in that vein goes up and it can transmit to other areas of the body, such as the gullet, and that can cause bleeding when they pop. We call that portal hypertension. We get fluid accumulation, increased risks of infection, reduced liver function. These are all things that I end up teaching medical students and other junior doctors. And then there's also the increased risk of cancer. There's of particularly hepatocellular carcinoma. So when we have liver cirrhotic patients, we try and screen these cancers regularly through ultrasound and blood tests, but they're really hard to pick up. Certainly, we see some people who get transplanted when they've stopped drinking for a while, and even when you transplant people, sometimes you find a small liver tumor which you can never see. So to wrap it all up, the first thing I'd say is when you drink alcohol, your liver breaks it down through pathways that produce acetaldehyde and shift your cellular chemistry. That shift makes it easier to store fat and harder to burn it. The breakdown process also generates reactive molecules that stress your cells, particularly your mitochondria. And alcohol also damages your gut lining, allowing bacterial products to reach your liver and trigger inflammation. That inflammation combines with the oxidative stress to create a cycle that can lead to progressive damage, from fatty liver to inflammation to fibrosis to cirrhosis and potentially cancer. And researchers are working on various interventions, things like N-acetylcysteine to boost glutathione stores, probiotics to help with gut inflammation. But they show some promise, but really nothing's quite as effective as stopping the alcohol intake in the first place, which is the major upstream driver for all these processes. So I'm not saying everyone needs to be completely abstinent, although that would be nice. But I think it helps to understand what's going on in your body when you drink alcohol. And knowing that when you drink might make you change your mind, reduce intake, stop intake, especially if you're someone that looks into your health, you track your diet, you exercise, you sleep well. It's worth factoring that into the picture, I think. Anyway, that's what I wanted to share today. I hope it was useful. And if you found it helpful, then please do share it with other people that may benefit. And I'll catch you in the next one. Thank you.